All right. Oh, cool. I'm on. Hi, everybody. Let's begin. We all ready? Awesome. So, welcome to this session on SPA's serverless and scalability. But before I begin, just want to ask just a quick question. Anybody here bought some bitcoins when it was cheap? No? Check this out. August 23rd, 2013. Bought a Bitcoin. Yeah, clap. Yeah. Best investment I ever made. You know, some people call me the Asian Warren Buffett. But my friends know me a little bit better though, because if you just look, you know, later on that day I sold half of it. But I kept the rest for 4 days, and I got rid of that. So, you know, what you take away from this is that I'm really good with money. So, and as good as I am with money, you can always do with a little bit more help. So, that's one of the reasons I listen to this podcast, Planet Money. Anybody listen to the Planet Money podcast? Yeah? Okay, love this podcast. And I have to say at this point, I'm not affiliated with Planet Money at all. They haven't endorsed me or Microsoft with this message, but I have spoken to them, telling them they have allowed me to put their image on the screen. And one of the things they figured out last year, they had a clever idea last year, they figured out that sometimes President Trump tweets, and when he tweets, sometimes he affects stock prices of companies. So this is an example where he tweeted something about Toyota Motors, I'm not too sure what it was, something negative about Toyota Motors, and immediately at that moment, the stock price dropped. Okay? So then they asked themselves the question, what if you could create a trading engine that made trades based off of Trump's tweets? And that's what they did. They created it. It's actually called BOTUS, Bot of the United States. And if you go on Twitter, you can actually follow BOTUS. Has a Twitter account itself, and every time BOTUS makes trades, we'll post on Twitter telling you about the trade that it made. But unfortunately, they shut it down. You know, they are a podcast, they're not an investment firm, so they shut it down, you know, a bit later, and everybody's a bit sad about this. So I decided to build my own BOTUS that would make money for me automatically. We all know where this is going, right? Yes. Now, don't worry, I made money. $61 today. Can I get an applause? Thank you very much. Thank you. Thank you. Now, admittedly, that's about 50 cents for every hour I worked on the project, but it's still a profit. But don't get excited, though, because I'm not going to teach you how to create your very own BOTUS. No. That's a secret for me to keep, right? This talk is about how to architect and scale a web app like BOTUS. And I chose BOTUS because it's a rather complex application. It's got a bunch of different moving parts. And I wanted to give an example which has just a little bit of meat on it when we're talking about how to scale and architect an SPA. Now, this is kind of like an example of what kind of BOTUS contains. So, I'd say kind of not even that long ago, as little as 2 or 3 years ago, it was a lot simpler, it was a lot clearer understanding how to architect an application like this. We would use a framework maybe like Express or some other web framework. And maybe it would have like a view layer, so perhaps like a template rendering engine or something like that, but essentially something where you pass in some data and it returns HTML, and you return that to the front end. Maybe I'm calling it an API, but essentially your controller, something that is between your view layer and the database, which has kind of a lot of your business logic. But this application is interesting because it's got other parts to it as well. It's got a Twitter feed, so something that runs outside of any kind of user interaction, listening for tweets. It's also got a trading engine on the back of the thing, so doing some real trades on the side. And all of this is kind of a one atomic code base. Okay, so when you deploy it, you're deploying it in one unit. So that means you're going to host it on a server, usually somewhere. And typically on Azure, that solution would probably be app services. Okay, that's how we would do it right now. So what this talk is going to talk about is we're going to talk about, well, that's how we would have done it perhaps 2-3 years ago, but a lot has changed in 2 or 3 years. You know, we work in an incredibly fast-moving industry, and we're at the cutting edge of that industry here right now. So a lot has changed in 2-3 years. So the topic of this talk is how would we architect, deploy, and scale this kind of application today. Okay? So, introduction, my name is Asim Hussain. You can find me on Twitter as Jawake. I blog about Angular and JavaScript on my website, codecraft.tv, and I'm something called a cloud developer advocate at Microsoft. So, what is a cloud developer advocate? Well, we're a pretty new team. We fall under the Azure banner, and our job is to be a conduit between the Azure team and developers such as yourself. So it's a two-way street. So we want to hear from you, any feedback, and we feed it straight back to the PMs, and it goes vice versa. So if you go to the link is at the bottom there, this is the CDAs that currently we have in our team. So we're not that many of us, about 60 right now. And quite a lot of us are here at Build. And in fact, if you've been to the expo hall, you've probably seen our area, which is called the CDA Lounge. So you might have seen this area or sat down there. That's our area. So if you go down there, you want to meet some of the CDAs. We're all hanging around in this place. And what you might see in the corner in the back there is a pen where we've got a couple of little bunnies. So if you want to kind of reduce a little bit of stress, you can go downstairs and stroke a few bunnies. Does that sound good? I don't know. You can stroke a few animals, and God, even watching it is calming. But yeah. And I'm also an instructor on a platform called Udemy. Anybody use Udemy here or heard of Udemy? Okay, cool. So I'm also an instructor on a platform called Udemy, and they recently added in subtitling or automatic transcription for my courses. And correctly, for the first time ever, they transcribed my name to awesome. Okay, I've been waiting for this day for many years. It's finally happened. So my name is Awesome, and this talk is going to be very Asim. All right, so going back to our old example, as I said, what we'd probably have if I was building Botus like 3 years ago is I'd have this kind of view layer, maybe the Express is kind of rendering something out as a HTML, back to the browser. But now, if we're building it today, we're probably going to build an SPA. So essentially, we're going to take that view layer and probably a little bit of the controller or API, rip that out, and build it as an SPA. But actually, what is an SPA? Okay. So this is the actual Botus application itself. You can see at the bottom, we've kind of loaded up one page. We loaded up a page from the server. Then it's basically going to render. And once it's rendered, we can then click around. And you can see the page is actually changing. You probably can't tell, but the URL is changing as well. But the important thing to note from looking at the network panel is you're not seeing any other pages being requested from the server. Okay? That's because an SPA is a single page application, which literally means only a single page is ever returned from the server. Okay? So what does an SPA look like on disk? Now this, if you use Angular, I'm an Angular expert. This is what the output of an Angular SPA build process would look like. So whether your application has 1 page or 10,000 pages, this is it. This is all you'll see in your output folder. And the key thing to see here is you'll only ever see one index.html file. That's all you will see. Once that index.html file gets loaded in the browser, it then loads all the other assets, all the other JavaScript files, that then bootstraps on the page, and then JavaScript takes over. Okay? So that's what an SPA is, and that's what we've done here. We've ripped out, if we took an Express application, we'd rip out the view layer, and we'd take it out, and we'd turn it into an SPA. But then, where'd you host it? Where'd you put it? That's the big question, right? And a decision I see a lot of people making is just to host it on an app server, so essentially on a server somewhere. I see that time and time and time again. Now, I don't know why. I think perhaps like you're just used to it because that's how you were taught to host an Express application. That's how you'll go ahead and host your SPA. Okay? But what I'm going to show you today is there's a better way. There's a better way that gives you better performance and is a lot cheaper. Maybe I should be saying things are a lot cheaper. A lot better performance. Okay? They don't like it when I give you cheaper ways of hosting stuff on Azure, right? But just understand kind of the method I'm going to talk to you, I have to explain a couple of concepts. Okay, it might seem quite basic, but stick with me. So that is the idea of a static versus a dynamic request. Okay? Seems pretty simple, right? So a static request is just a request for a URL that returns the same data no matter what. So if two users on two different machines request the same URL, it will return the same data. If the same user requests the same URL over a certain period of time, it returns the same data. It's a static request. The opposite of that would be a dynamic request. So the same user makes the same request, the same URL over two different time points. It returns different data. It's a dynamic request. So static versus dynamic. All right? Bit of a quiz. I like quizzes. Keeps the audience on their toes. So, if you requested a JPEG file, would that be a static request or a dynamic request? Static? Anybody think it's dynamic? No. Good. Would have had to ask you to leave. So, a static request, right? What about the home page for your website? Is that static or dynamic? Depends, right? Well, I used to make my home pages dynamic. So if you're a logged-in user versus a non-logged-in user, I would show slightly different data. Yeah, that's what I used to do for quite a while. But if you do that, if you start doing making it dynamic, then you can't take advantage of a bunch of features I'm going to show you next. Okay? So you can stay for now. It's okay. So yeah, it depends, right? How about like if you had like a profile page? So my logged in page might look different to your logged in page. Would that be a static or a dynamic request? Dynamic. That's right. Anybody think static? Good. All right. So then, next question: is an SPA dynamic or static? Static. That's right. I showed you an output folder. Unless you change the output folder because you changed the application, it's not going to change. Okay? So an SPA is static. Why is that important? Well, it's important for a bunch of different reasons in terms of performance. One of the most important ones is caching. Okay? Because if you request a URL and that's going to return the same thing time and time again, then you can take advantage of a bunch of different caching features on the internet. Okay? The most famous of which, the most commonly known, I suppose, is browser-based caching. Okay? So your browser itself will cache resources if it's a static asset, if you set it up rightly. But actually, between your browser and the server, there's quite a bunch of other caches on the internet. Okay, there's quite a bunch of other ones. The most famous one, or the most well-known one, would be a CDN. Okay, so Content Delivery Network. Now, if you're using a CDN, you know you're using a CDN. It's your CDN because you've got to pay for it. But another really interesting one I love to use, if I can, is a proxy cache. Now, you're going to find it a lot less. I don't know if we're still using proxy caches in the United States, but definitely in countries which have poorer internet connections, you'll find they're using a lot of proxy caches. And proxy caches are used by the internet service providers. So in the local region, they will have their own cache, which is caching requests coming through, just like a CDN, just like a mini CDN, just for that internal kind of regional area, just to speed things up for their users. And proxy caches are amazing because you make a request, or your user makes a request, and it's going to get served by the proxy. It's never going to hit your servers. Isn't that amazing? Free hosting. Yeah? I told you I was good with money. Yeah? But how do we take advantage of that? Okay, well, you do that by using the whole host of headers. I'm not going to go through it exhaustively. There'll be links in the slideshow that you can take a look at with resources where you can find a lot more information about this. But this is the most common one. It's the cache control header. So if when you're returning data back, you set this header in the response, you can give it different parameters which just inform the different nodes, the different caches in that chain, how they should be treating this certain asset. So public means this is common data. This is going to be same for multiple different people. So you can store it on those shared caches. Okay. And then max age. Can you see that? Good. Max age just tells like kind of the browser how long to cache it for. So 5 minutes. Because you don't really want to store, especially kind of HTML kind of content for much longer than that, even though it's an SPA. And you can use things like smax age, which basically are just parameters to inform the shared caches, the intermediate caches, how long to store it for. Okay. So one really big reason why making something static can speed up the performance of your application a lot and also reduce your costs a lot. But another reason for serving static assets is that different web servers have different performance characteristics when serving dynamic versus static requests. Okay, they have different performance characteristics. Now I'm going to give 2 examples here. I'm going to give Node versus Nginx. I don't know if you know both of those web servers. So obviously, hopefully you know Node. Both of these are really, really common kind of web server technologies. The first one, Node. I call it a dynamic web server because it's kind of optimized for returning different responses for each request. And it's kind of using JavaScript to kind of handle a lot of that for you. But even though I call it a dynamic web server, it can still be configured to return static assets as well, right? So, but then you're still going through a JavaScript layer in order to do that. I've got a quick test here. So I'm just very, very simple, very basic. Don't take this as a scientific certainty. But I'm using Apache Bench. I've created a very, very simple Node application. I'm just going to request 10,000 requests from it on the screen. So watch the screen now. OK. It's OK. It's not too bad. Pretty good. I think the time per request is 0.4 milliseconds. So pretty good, right? If I was to do the same thing with Nginx, now remember Nginx is much more like a static web server. It's much more optimized for that. So it's written in C. There's no intermediate layer. If you're using C, there's some really low-level APIs you can do, which can just read a file and stream it back out to the HTTP response. So it's very, very fast. I'm going to show you just the timing for that. Exactly the same test case, but now being served through Nginx. OK. Did you all see that? Did we blink? OK, so Nginx is a lot faster. Well, that's actually a pretty contrived example there, to be honest with you. What I'm saying is the out-of-the-box configuration, Nginx is faster than Node. You can configure Node or tune Node so it does perform a lot faster. But it's always going to be a little bit slower than Nginx because you can't really compete with like a C application, right? I want to say that because I love Node, and Node's an amazing web server. I didn't want people to walk away from here thinking that I'm disparaging Node in any way at all. But the thing I want you to just kind of like take away from this is when serving static assets, you use a web server that is optimized for returning static assets. That's what you've got to do, okay? So is there a service on Azure which is optimized for serving static assets? Is there one? Yeah, that's right, storage, right? That's why we recommend to serve your SPAs of Azure Storage, right? Because storage is optimized for serving static assets. It's much, much cheaper than serving the same application from an app service. And it's just simpler to use as well, right? And it's faster. All right. So we take our SPA. We're not hosting an app service. We're hosting it on storage. All right. But what about those other boxes? What about the rest of them? What do we do with the rest of those parts of our application? And before I kind of go into that, we're going to cover the topic of serverless. So who here has heard of serverless, used serverless technologies? Okay, 50% of the room. Okay, cool, perfect. I don't care, I'm going to explain it again for everybody. So I have my own definition of serverless. It gets me into trouble sometimes, but it's my definition and I believe in it. So this is an example of kind of a performance of an application. So the x-axis is time and the y-axis is load. And over time, maybe the load of your application changes. Okay, back in the day, I do still remember being called up by senior management saying we need to have some emergency capacity planning. And you have to sit there and figure out what the maximum load is going to be over the next 6 months, tell them what it is, and then they go away and buy the servers to handle the load, right? And that's what we used to do, and we always used to do it really badly. But basically what we were asked to do, we were asked to predict the future load and purchase the service to handle it. Now, the word predict is an important word here. So then what the world moved on and we started to be able to spin up and spin down virtual machines using Azure, of course. What else? And this is what we perhaps used to do, but what if your algorithm was just a little bit off, and as it scaled up, as the load started to increase, you'd onboard just a whole bunch of servers, then it turns out you never really needed them. Then as the kind of load started to come down, you kind of spin down those servers, but you spun down too many servers, so the performance was affected with your application. It's kind of we're still having to deal with this job of predicting our future load. It's a really, really tough problem to solve. Okay? And then kind of another annoying thing is you still have to pay for these servers that you're not even using. What you really want is you want something like this. Okay? So someone else does the scaling for you, and then you only pay for what you actually use. And that's the definition I love of serverless, is you pay only for actual usage and not for predicted usage. Okay? And it auto scales as well. Quiz time. Is Azure Storage serverless? Interesting question. Who thinks it's serverless? 50%. Who thinks it's not serverless? Leave. No, joking. So my argument is this, and I'm probably going to be unique in this thing, is this: if it looks like a duck, if it quacks like a duck, if it walks like a duck, it's probably a duck, right? So without Azure Storage, you don't need to predict future load. I mean, it has got servers underneath and is going to scale out those servers for you, but whatever, you just pay for whatever you use. So in my books, and actually a few other people's books, storage is serverless. Boom. So given that storage is serverless, and given that we're hosting our SPA on storage because it's static and it's the best solution for static assets, then can we make the rest of our application serverless as well? Is that possible? And specifically what we're talking about here is kind of this API controller part. Can we take that and can we make that serverless also, just like we made our SPA serverless? Okay. And we can. I know if half of you put your hands up before, but we can, because we've now got a solution, a type of solution called FAS, a serverless solution called FAS, functions as a service, right? And to explain this, I like to just go through the history as well, right? So back in the day, remember that day? We all had on-premise, pre-cloud. And that, if you bought the hardware, you stuck it in a data center somewhere, but the important thing was you were on the hook if the hard drive failed. You had to fix it. Okay? We didn't like that, so we invented infrastructure as a service, VMs, virtual machines. Somebody else is now responsible for the hardware. But you're still responsible for the operating system, if you're doing a website, a web framework, and the individual functions which respond to each URL. So we went a bit further, and we made for you PaaSes, platform as a service. We took over the operating system. You just had to put the web framework in and handle the functions as well. And now what we have is FaaS. which is basically you just give us your functions. You don't even bother with your web framework. You just give us your individual functions which you want executed per URL, and we'll handle everything else for you. And that solution from Azure is Azure Functions, right? So you get charged by gigabyte seconds plus executions. So again, you don't have to predict future load. You only get charged for actual usage. But it does have limitations. It's limited to on the consumption plan, it's limited to 5-minute runtimes, and it's stateless. There's many different ways of using Azure Functions. My favorite way is with VS Code and the Functions extension. I don't know if you've ever used it, but with the Functions extension, you can just click a button, create a function application, click another button, create an individual function within your function application. And because of VS Code, the actual debug configuration has already been set, so you just drop a breakpoint in, hit F5, and we're running and debugging a function application within about 30 seconds. Pretty awesome. So today I wouldn't use kind of Express to host our API. I would basically take that functionality, I would rip it out, and I would just host that on Azure Functions. And then now we've got two parts of our application running serverless. Okay, that's why I think SPAs and serverless are a perfect combination of technologies. But what about the rest? What about the Twitter feed and the engine itself? Like, where do we put those? How do we architect those these days? Right? Now, you could, if you wanted to, perhaps take that stuff and just host it as an Azure function. Right? With Azure Functions, you can actually have it run on a timer, on a cron job, on a schedule. So you can actually have it maybe wake up every minute, check to see if Twitter's got any new tweets, and then run again. You could do that if you wanted to. But it has its drawbacks because, as I said, functions are not stateful. Especially with stuff like a Twitter, like a trading engine, you probably want to have something that doesn't shut off after 5 minutes in the middle of a trade, or maybe you want to have some retry logic or something like that. Okay. So when building serverless architectures, there's a need for something else, something that I like to call, or we like to call, orchestration. Okay. Need something that's kind of like managing the whole process. It needs to be something that's long running. Can't just be lasting for 5 minutes. And it needs to be stateful as well, at least stateful to a degree. Enough to do retries, for instance. So one thing you could do, and I still see people doing this as well, which is they just keep their other business logic, their other part of their application, keep that on an app service. An app service is just a server. It's going to stay up all the time. It's going to be stateful. It's long running. It can do orchestration for you. Okay? But it's not serverless. And we love serverless here. Like, we're really getting into serverless. We've got two parts of our application on serverless. We're really enjoying it. We want to get the rest of our application on serverless. So what are kind of our serverless solutions for orchestration? One we've got here, and one I love using, is logic apps. Anybody here use logic apps? Okay, a few in the audience. Love them. So with logic apps is basically it's like a coding workflows with a visual designer. So for instance, in my application, I've got a Twitter connector. So the whole process starts off with listening to Twitter for tweets. There's a bunch of different connectors. We've got a huge library for, I don't know how many, we've got hundreds and hundreds and hundreds of connectors. Then we can kind of link them together to other actions in our workflow. So actually for this project here, we also need to do some AI. We need to do some sentiment analysis, analyzing those tweets, figure out if it's positive or negative, what company is talking about. And so we can actually take the output of those tweets and pump them into other cognitive services APIs and enrich that Twitter data with some sentiment scores as well. Okay, you can just do that with a visual designer, a couple of clicks, really easy. And the final thing you can do, well, not the final, you can do a whole bunch of other things, but another thing you can do is just link it in to the trading engine, the actual engine itself, which is again another Azure function. Okay. And logic apps are themselves serverless, okay? Because you only get charged by the number of executions. You make 0 executions, get charged 0. Underneath, it's got server, it's going to scale up and down for you, whatever, but you don't have to worry about that. You're only ever going to get charged for however much you use. You don't have to predict anything. And it has kind of a longer, the runs can last for like up to 90 days, I believe now. All right. So now I moved the Twitter feed code over to Logic Apps. And then the actual engine itself is actually another Azure function. And Twitter feed is just the thing that's orchestrating that functionality. So now we don't need our app service anymore. We get rid of that. Because the entire application is now running serverless. Okay? You never have to worry about scaling issues. Your DevOps overhead is really, really low. Okay? And as a developer, all you need to focus on is what you do best. Shipping code. Exactly. Just a little side note for that. I think we just had some announcements today and yesterday at Build. We now have a feature of Azure Functions called durable functions. Okay, it just went GA for C# and it's now gone preview for JavaScript. Durable functions are an extremely exciting technology. We're the only company that's got anything like this. And what durable functions are a long-running Azure function. So I told you before that Azure functions turn off after 5 minutes. A durable function can last much, much longer. It's a very clever technology underneath. Essentially, the function can basically fall asleep, exit from memory, and come back up and restart from exactly where it left off. So it can literally, your function can pause for 10 days and then come back up later on and start executing again, and you won't get charged for those 10 days. So now we've got another mechanism of being able to orchestrate our code that's not a logic app. And perhaps this is a good solution if the logic apps themselves is just not as complicated, it doesn't provide you with the rich enough syntax to be able to do your orchestration. If you just do need to write your orchestrator in code, then durable functions are a solution for you. So in summary, SPAs are static, right? We're just serving a folder that won't change over time. Well, unless you change it. So we want to serve our SPAs using something that's optimized for serving static assets, and that is on Azure Storage. Okay? But Azure Storage is, and I explained what serverless was, and I also explained that Azure Storage, in my books, is serverless. All right? So if Azure Storage is serverless and we're serving our SPA on Azure Storage, we want to make the rest of our application serverless as well. And to do that, we take the API and we serve that with Azure Functions. And then we need to orchestrate the whole process. And for that, we can either use logic apps, or now we can start using durable functions as well. So that's it. Thank you very much for your time. If you want, you can follow me on Twitter as Joik. I can wait. No?